Hello everyone, I welcome you all in this video tutorial of class 12th, and today we are going to start a 7.5, right? So I hope that you all have completed up to 7.4, and I've told you that you can send your doubts in my email ID, and also you can do the comment, right? So just write down the heading 7.5, and the topic is integration by partial fraction. Write down integration by partial fraction. So you can ask that, ma'am, this terminology is very new, partial fraction. So what it is, right? Now, partial fraction is all related to your few, different form of your given function, where your fractions will be divided in the two parts. As suppose I have one question like this. Suppose the function is given as 1 upon x plus 1 and x plus 2. Now I want to write this function partially, right? In terms of partial fraction. It means in terms of two parts. So I can write it as 1 upon x plus of 1 minus of 1 upon x plus 2. Now solve it. So this will give you x plus 1, x plus 2. And this will be x plus 2 minus of x minus 1. And you can see it is again giving you 1 upon x plus 1 and x plus 2. It means we can write this function as this. Okay, so ये जो process था, that we have written this 1 upon x plus 1 into x plus 2 as 1 upon x plus 1 minus of x plus 2. This is known as your partial fraction. That what you're doing here, that you're partially fractioning your given functions, okay, according to the different forms, and that forms are listed below. I'm making one table, and we'll see that this is not only the form of your question, there may be many other forms. So just write down that forms. Just make a table. Just make a table like this, and note it down with me. I'm writing the forms of the partial fraction and how we'll solve it. What will be their solution form? Just make a table like this. Just write down form of the rational fraction, form of the rational fraction, and form of the partial fraction. Form of the partial fraction. Okay, so there will be 4 or 5 varieties in this rational to fraction. So just write down. As you can see that this is the first variety, right? So first variety is px plus q. Suppose my function is like this, and it is x minus of a, x minus of b, right? Where a is not equals to b. Then you will partially fraction it like this: a upon x minus of a plus b upon x minus of b, as I have done here, right? Second, now one more question is arising in your mind. I know that, ma'am, what is the value of this a and b? This we need to find out. We'll do it in the question. Just write it down first. Px plus q upon x minus of a square. I can write this as a upon x minus of a plus of b upon x minus of a square. Now the third. Suppose we have a form px square plus qx plus of r, and upon there will be x minus of a, x minus of b, x minus of c. So I can write it as a upon x minus of a plus of b upon x minus of b, and then x minus of, and then x minus of c plus of c upon x minus of c. Okay. One more. Suppose our variety is px square plus of qx plus of r upon x minus of a square and into x minus of b. So I can write it as a upon x minus of a plus of b upon x minus of a whole square plus of c upon x minus of b. One more variety is there, fifth number, px square plus of qx plus of r upon x minus of a x square plus of bx plus of c. This can be written as a upon x minus of a plus of bx plus c, and this upon x square plus of bx plus c. Now I want to tell you a few things about this, formulas you can say, but it is not actually the formula. These are the forms that whatever the fraction we are having in the left hand side, you can see that the degree of your denominator is always greater than degree of numerator. First thing, first asterisk point, that degree of denominator is greater than degree of numerator, right? And the second thing is, you can see when you'll find out the LCM of your right hand side, LCM of your right hand side, you'll get the same value as this denominator, right? You can check, है ना? So we have divided this rational fractions as partial fraction, so that we'll get the same denominator if we'll take the LCM of the partial fraction. Okay, so this is these five are the few patterns of your rational function to fraction partial fraction, but you'll come to know about it when we solve few questions. Okay, so just keep it in your mind, and let's start today's session 7.5. I'm just rubbing it. I'm taking one question. So I'm taking the very first question of your exercise, and it is x upon x plus 1 and x plus 2. You can check it. First, you need to check whether the degree of denominator is greater than degree of numerator or not. Why I'm telling this sentence, because there will be two kinds of fractions. There will be two kinds of fractions. First is proper fraction, proper fraction, and improper fraction. Improper fraction. So in proper fraction, degree of numerator will be less than degree of denominator. But in the improper fraction, degree of numerator will be greater than or equals to degree of denominator. So until and unless you have this thing, the questions will be very easy, right? You'll directly change your rational fraction into the partial fraction, and you'll solve the integration. But what about the improper fraction? I'll tell you about it, that this will be solved after doing the long division. After doing the long division, it will become proper fraction, and then we'll solve the question. Okay. So in this 7.5, we'll discuss about your proper and improper both the functions. But firstly, we'll discuss this kind of question, proper fractions. Okay. You can make a note of this fraction, types of fraction, proper and improper, in your copy, so that you'll come to know that where we are using the long division and where we are directly solving these questions. Okay. So guys, let's have the question number one. And the question number one is, it is x upon x plus 1 into x plus 2. You can check by your table that it is the question of very first variety. So I can write it as a upon x plus 1 and x plus 2. I need to find out the value of a and b, right? So these are the steps. I need to take the LCM of this x plus 1 and x plus 2. Now it will become a into x plus 2 and b into x plus 1. This and this will be cancelled out. It is x and it is a into x plus 2 and b into x plus 1. Whenever you have simple brackets like this, the steps after this step will be, just put x plus 2 is equals to 0 and x plus 1 is equals to 0 to find out the value of a and b. Okay, so if x plus 2 will be 0, x will be minus 2, and when x plus 1 will be equals to 0, then x will be equals to minus of 1. So I'm putting the values of this x in your this part. So it will be minus of 2 and a into 0 plus of b into minus 2 plus of 1. So it is coming out as minus 2 and b into minus of 1. So value of b is coming out as 2. Okay, what about this? This is minus 1, a into minus 1 plus of 2 plus of b into 0. So it is minus 1 and it is a into 1. So a is coming out as minus 1. Now put these two values in your equation number 1. So this x upon x plus 1 into x plus 2 will be equals to minus 1 upon x plus 1 plus of 2 upon x plus 2. Okay. Now my duty is to integrate this, right? My duty is to integrate this. So I'm writing operator of integration here, here and here also. Okay. Now guys, you can see that your question becomes very easy. Why? Because the right side is simply solvable by your formula log x. है ना? So this will be minus of log x plus 1 and this will become plus of 2 log x plus 2. Okay, and plus c. So this is your answer. Okay. So whenever you'll have this kind of question where you'll be having two different brackets in the denominator, or you can see that your function is in the rational form, then you'll solve it by using the partial fraction. Okay, let's have one more question. So this is your question number 1. I guess this is easy to you and you come to know about the concept and the solution part of this question. I want to tell you the hint of question number 2, that in question number 2 the question is 1 upon x square minus of 9. It x square minus of 9, so you can write it as 1 upon x minus of 3 and x plus 3. After that you'll approach the question by this method, by this by taking the help of this question number 1. Okay, now let's have one more question. I'm taking a question which is quite different than this one. I'm taking question number 7. It is x upon x square plus 1 and x minus of 1. Okay, so I can uh, how it is in which form? Maybe it is in the fifth or fourth form. You can check. I can write it as a upon x square plus 1. Is it correct? Tell me. No. Why? Because this is in the form of bx square plus of cx plus of d. Right. So I need to write it in the form of, I need to write it like this. When we have the simple bracket, then only I can write a. But we have a polynomial like this, I need to write ax plus b in the numerator. Okay, and you can see that the second bracket is very simple. So it is c upon x minus of 1. One more thing I want to tell you. Whatever the degree you have in your denominator, you must have degree just less than 1 in the numerator. As here you have degree 2 and here you have degree 1. Here you have degree 1 and here you have degree 0. Okay, so this is the whole thing about this ax plus b and this c only. Okay, now do the same process which you have done for the question number 1. This is ax plus b and this is x minus of 1 plus of c x square plus 1 upon x square plus 1 and x minus of 1. So this and this will be cancelled out. It becomes x is equals to ax plus b x minus of 1 plus of c x square plus 1. Now guys, I just want to tell you that in the previous question, I have made the two brackets as equals to 0 to find out the value of a and b. One more thing you can do, as I'm doing in this question, you can multiply the whole things. It will be ax square minus of ax plus of bx minus of b plus of cx square plus of c. Now take the coefficient of x square together, x together and constant terms together. So it will be a plus c x square and the terms of x are like this, b minus of ax and the constant terms are c minus of b. And in the left hand side you have x only. Now just do the comparison. Comparing coefficients of coefficients of x square, x, and constant terms, constants. Okay, when you're comparing the coefficient of x square, x, and constant, you can see the coefficient of x square in the left hand side is 0 because there is no x square wala term, right? So it will become a plus c is equals to 0. Now coefficient of x, compare coefficients of x. You can see the coefficient of x is 1 over here and here it is b minus of a. So it is 1 is equals to b minus of a. Now the constant terms. You can see that there is a no constant term in the left hand side. So it will be 0 and it is c minus of b. Just take b left hand side, you can see that b is equals to c. Okay, and here you can see that a is equals to minus of c. So just put the value of a and b here. So it is 1, value of b is c, it is minus of c, so it becomes plus c. So it is coming out as 1 by 2. C is coming out as 1 by 2. So value of a is minus of 1 by 2 and value of b is plus of 1 by 2. Okay, just put this all value in equation number 1. Okay, I'm putting it, wait. So your question will become very easy, na? It will be x upon x square plus 1 and x minus 1. You can rewrite this as ax plus b. Your value of a is minus half and this is half upon x square plus of 1. Okay, plus of c. C is half and it is x minus of 1. Now I need to do the integration of this, integration of this, integration of this, and integration of this. Okay, so this will be 1 by 2 is common. It becomes 1 minus of x and it is x square plus of 1 dx plus of 1 by 2 and it is 1 upon x minus of 1 dx. I can, I need to do one more thing that it is 1 by 2 and one more step I need to do. I'm splitting 1 and x, 1 upon x square plus 1. I'm writing it separately, then minus of x upon x square plus 1 dx. Again, this is the whole bracket and this is 1 by 2 and it is 1 upon x minus of 1. Why I have done this? Because now it becomes my formula tan inverse x and I can put t over here. Let x square plus 1 is equals to t. So it will become 2x dx is equals to dt and it will be x dx is equals to dt by 2. So we have x dx. Okay. So just do the integration. It will be 1 by 2. It becomes tan inverse x, this become tan inverse x and this will be dt by 2, right? So 1 by 2 is here and 1 by t will become log t. Okay, and this is 1 by 2 and this become log x minus of 1 plus of c. Just substitute all the values, do the multiplications. So this will be 1 by 2 tan inverse x minus of 1 by 4 log x square plus 1 and this is plus 1 by 2 log x minus of 1 plus of c. Okay, so I guess you all got the solution and this is how you'll understand about what is the variety of your rational fraction and in which kind of partial fraction you will made. Okay, so we have done question number 1 and 7 guys and I hope you're getting the idea behind your partial fraction. You have 5 different forms. Go through your book, check your 7.5. You'll get many different questions from different forms of your partial fraction. So guys, in this video, I have covered these 2 questions. I just want to discuss one more question, which will be, related to your improper fraction. You can check that it is a proper fraction. Why? The degree of denominator is greater than the degree of numerator. One more question I want to discuss, which is related to the improper fraction. Let's have that. Improper fraction. Um, I can take, question number. I'm just looking into your book so that I can find any question which is related to improper fraction. Improper fraction is question number 12. Question number 12. It is given as x cube plus of x plus of 1 upon x square minus of 1. you can check here that degree of denominator is less than degree of numerator. Okay, इनके पहले जितने भी questions we have done, they are having just opposite relation. So I can say that this is my improper fraction. And I have told you for improper fraction, I first need to change in the proper fraction by using the long division. So I'm writing it as x square minus of 1 and it is x cube plus of x plus of 1. I'm using the long division. X multiply kiya apan ne, it will be x cube minus of x. So this is minus and plus and 1 is left. Okay. So now this is your quotient, this is your remainder. Okay. Now x cube plus of x plus of 1 upon x square minus of 1 can be rewritten as. See, we have done such kind of question when we were in the small classes, right? जब हमको normally division पढ़ना होता था, है ना? तब अपन इस तरीके से किया हुआ है. अभी भी अपन सेम चीजें अप्लाई कर रहे हैं यहाँ पे, सेम फिनोमिना को अप्लाई कर रहे हैं, डिवीजन वाले फिनोमिना को, और वापस से अपन इसको लिख के देखेंगे. ठीक है, सो कैसे लिखना है ये समझिए. हमने यहाँ पे लिखा x प्लस ऑफ 1 अपॉन एक्स स्क्वायर माइनस 1. ठीक है, जस्ट चेक इट, आपको ये चीज वापस से मिल रही है कि नहीं. हम इसको चेक कर लेते हैं. ये हो जाएगा एक्स क्यूब माइनस ऑफ एक्स प्लस ऑफ 1. ठीक है, एंड डिनोमिनेटर में हो जाएगा आपका एक्स स्क्वायर माइनस ऑफ 1. देयर इज अ फिशी थिंग विच इज कि भाई मेरे को एक माइनस एक्स मिल रहा है. मेरे को क्वेश्चन चेक कर लेने दीजिए कि माइनस है या नहीं है. कुछ तो भी प्रॉब्लम है इस क्वेश्चन में. Oh, I have done one mistake. You can see guys, remainder is not 1. X and x, it is 2x and plus of 1. So it becomes 2x plus of 1. So it will be 2x plus of 1. Now you can see that it is x cube plus of x plus of 1 upon x square minus of 1. Take one small mistake I have done. So guys, about this you are already knowing by your few division methods, that I can write it like this. It is 2x plus 1. कैसे लिखा अपन ने? We have written the remainder over here, divisor over here, and quotient here. Okay. Now you can check that by writing x plus 2x plus 1 upon x square minus 1. This is the different part and this becomes as my proper fraction. है ना? Now I need to solve this 2x plus 1 upon x square minus 1 by using the partial fraction. Right? I can write it like this. Just use that. Now this will become very easy for you. So it is 2x plus 1 upon x minus of 1, x plus of 1, and this will be a upon x minus of 1, x b upon x plus of 1. I'll repeat the same process what I have done for my question number 1. So this will be x plus 1 is equals to 0 and x minus of 1 is equals to 0. Okay, so x is minus 1, x is equals to 1. So it is 2 minus 1 plus 1 is equals to a into 0 plus of b into minus 1 minus 1. So it is minus 2 plus 1 and b into minus 2. So it is minus 1 and it is minus 2. So it becomes half. Right, now when x is equals to 1, this will be 2 plus 1 and this is a 1 plus 1 and plus of b into 0. So it is 3 a 2 and it is coming out as 3 by 2. So I got the value of a and b. It is 3 by 2 and 1 by 2. Okay, so this was my equals to with your given question, your equation number 1, and your this part will be equals to equation number 2. So just write the whole thing once again. X cube x plus 1 upon x square minus 1. There was 1x plus 2x plus 1 upon x square minus 1 can be written as a upon x minus of 1, which is 3 by 2 upon x minus of 1, plus of b, which is 1 by 2 upon x plus 1. Okay, so I have rewrite my equation number 1. Now what I need to do, I need to perform the integration. So this is integration, 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 and integration. Okay, now you can see that question becomes very easy. It will be x square by 2. It is 3 by 2 log x minus of 1 and plus of half log x plus of 1 and plus of c. So guys, this is my answer. I hope you all, got to know about the concept of make modulus and over here. I hope you all got to know about the solution of improper fraction, that how do we have proceeded. This was this was the long division. After doing the long division, I got a proper fraction. I have changed that proper rational fraction into the partial fraction, and after that I have rewrite the whole equation number 1, and then I have integrated it. Okay, so guys, thank you for watching this video. I have done all variety of your 7.5. If you have any kind of doubt, please do comment in the comment box and kindly share this video and do like this video, subscribe my channel. Thank you for watching. We'll meet in the next lecture with the new